In this video, we are going to see the round-robin scheduling in OS. Round-robin scheduling is a preemptive scheduling in which every process gets executed in a cyclic way. That is, a particular time slice is allotted to each process, which we call as time quantum. Every process which is present in the queue for processing, the CPU is assigned to that process for that particular time quantum. If the execution of the process gets completed in that time quantum, then the process will get terminated. Otherwise, if it has its burst time excess of that time quantum, it will go into the ready queue and will wait for its turn to complete its execution. To explain this round robin scheduling, we are taking 6 processes whose arrival and burst time are given this table. The time quantum we choose is 4 units. In round robin scheduling, we know that there is a time quantum, and for that particular time quantum only a process at a time it executes its execution. Then it if the burst time is excess of that time quantum, then it will move to the ready queue. First, initially at time 0, the process P1 will be executed for this time quantum of 4 units. So in the starting in ready queue, there will be only one process P1, that is, which has its burst time of 5. Now, while the execution of P1, other processes like P2, P3, P4 and P5 will arise for execution in the ready queue. That is, while P1 is executing for the time quantum of 4 units, P2, P3, P4 and P5 arises for execution. They will be present in the ready queue. That is, P2 will have it's having a burst time of 6, and P3 will have it's having a burst time of 3, and P4 it's having a burst time of 1, and P5 5, and P1 has its burst time for 5. So after executing only for 4 units of time quantum, it is placed at the back of the ready queue with its burst time of remaining 1 unit. Then during the execution of P2, other process like P6 arrives in the ready queue. Also, we know that P2 has not completed, since it has 2 units of burst time left, because it has the burst time of 6. So we again this P2, after executing for 4 units, it will go back to the back in the ready queue with burst time of 2 after this P6. Now P3 will be executed for 3 units, since its burst time is only 3. That is, for process P3, the burst time is only 3. It will completely get executed, and it will not be added at the back of the ready queue. Now P4 it gets executed, since it has only its burst time of 1, it is executed completely and it will not be added at the end of the ready queue. And next is the process P5. It has 5 units of burst time, and it will get executed only for 4 units of time quantum, and then it is added at the back of the ready queue. And now process P1 is at the front of the ready queue. It has remaining its burst time of 1, so it can complete its execution. And Then after P1, then we have P6, P2 and P5 in the ready queue. First P6 will be executed. Since it has 4 units of its burst time, it can be completely executed in the time quantum of 4 units. Then the process P2 with the remaining burst time of 2 is there. Then it will be executed. Now we can see now we have only P5 in the ready queue, and also it also will be executed next. Now we can prepare the Gantt chart. The Gantt chart is we know that it's a graphical representation of scheduling. For this particular round robin scheduling, considering the processes P1 to P5, we can prepare a tabular column of all the measures that will assess a particular scheduling algorithm. uh, we know that turnaround time is equal to the completion time minus the arrival time, and the waiting time is equal to the turnaround time minus burst time. Based on this, we can calculate these values. First, we can explain the Gantt chart. This Gantt chart is having the process that is the sequence of execution of these processes, and it is having the completion time also. So for this completion time value, we can see it from the Gantt chart. First, let me explain the Gantt chart. For that is first based on the previous explanations, we can see P1 has first P1 will execute for 4 units of time slice, and then P2 comes, then it will complete at the 8 units of this time slice. That is that completion time will be 8 milliseconds, we can say. Then for P3, it has burst time is only 3, so it will complete at the 11th millisecond. Then P4, it is having only one burst time, 1 unit, so it will complete at the 12th millisecond. And P5, it is having 5, so first only for 4 it will execute first, so it partially it will complete its execution at 16. And then P1, it will have only, it is having remaining one, so it will complete that is P1 will completely complete its execution at 17th millisecond. And then process in the ready, then process 6 is there at the ready queue. It is having burst time of one, correctly it is having the burst time of 4, so it can be executed with the time quantum, so its completion time will be 21 millisecond. Then P2 is coming. It's having a remaining burst time of 2, that we know, so it will complete its execution at the 23rd millisecond. And then process P5 completes its execution. The last, it's completing its execution of remaining one unit of burst time, so it will complete its execution at the 24th millisecond. That is, P5 is completing its execution at the 24th millisecond. That is given in the tabular column. That is, completion time can be attained from the Gantt chart. Then turnaround time, this for P1 alone we are calculating. To calculate the values for P1, turnaround time for P1 is equal to 17 minus 0, that is 17 is the completion time for P1. And then waiting time for P1 is equal to 17 minus 5, that is burst time of P1 is 5, so it will get the value as 12. So for remaining values, based on this example, we can calculate the remaining values for the other processes also. Then we can calculate the average waiting time as this 76 divided by 6, that is 12.66. These are the values that measure and that are used to assess a particular algorithm. For this example, and for based on this round robin, if we use round robin scheduling for these process of this arrival time and burst time, then we get these measures as their values. So according to these, the scheduler will choose which particular algorithm can be used for the process. Then advantages, we move to the advantages of and disadvantages. Advantages, it is easy to implement and we deals with process without any priority, can say. Then disadvantages, it is uh, very difficult to decide a particular time quantum for the process, since round robin scheduling depends upon time quantum. If the time quantum is higher, then the response time of the system also will be higher. If the time quantum is lower, then there will be more context switching. That is, then every time the context switching has to be done, so this causes higher context switching overhead. Subscribe to my channel if you feel contented.